Okay, so let's go to topic 7, which is Form 4 Chapter 5, Form 4 Chapter 5, Ionic and Covalent Bond. So for this one, you need to know how to describe. This is a very popular essay in SPM and in Form 4 final exams, that they always ask you about how actually all the ionic and covalent compound is formed. So for example, potassium is oxygen is 8, proton number is 8. So electron arrangement will be 2.6 and 6 valence electrons. Then for potassium is 19, it has an electron arrangement of 2.1 and 1 valence electron. In order to become stable, so the potassium need to donate out the electron, because to become octet, right? So potassium is 2.8.8.1. They need to donate out 1 electron so that it becomes stable octet electron arrangement. Then for oxygen, right, 2.6, they need to receive 2 electrons in order to become octet also. So it becomes 2 minus. Okay, so here is explanation. But they don't lost 1 valence electron to achieve stable octet electron arrangement. So oxygen atom receive 2 electrons into the valence shell to achieve stable octet electron arrangement. Okay, then after that, they'll become K plus and O2 minus. So oppositively charged, positive negative charge, are strongly attached by a strong electrostatic force. So this is the brief idea of how do you write this one. Then for the covalent bond, quite popular will be the carbon and chlorine. So for carbon is 2.4, you have 4 valence electron. So 4, how to become 8, you need 4 more. So you see, carbon 2.4. Then chloride 2.8.17. So this one need 4 more. This one need 1 more. Okay, so you cross, you become CCl4. CCl4 means you have 1 C at the middle here, then connect with 4 chlorine. Then the explanation need 4 more to achieve stable electron arrangement. So chlorine atom has electron arrangement of 2.7 and 7 valence electron. You need 1 more to achieve stable electron arrangement. So 1 carbon will combine with 4 Cl. CCl4 is 1 carbon combined with 4 Cl. Then 1 carbon, if you need 4 more, you will contribute 4 for sharing. If you need 1 more, you contribute 1 for sharing. So it becomes CCl4. Okay, so this is the explanation for the what we call the ionic and covalent bond compound, how they form. Then you need to notice that ionic and covalent, they always ask you about the physical property. So physical property of ionic compound, first, they have high, it's always opposite. So ionic compound has high melting boiling point because they have strong electrostatic force between the ion. So the forces between them is electrostatic force. Then for molecule, right, because covalent is molecule, they are neutral. So between 2 molecules, the force is very small. We call them as force of attraction, or you can write van der Waals force. So the melting point is very low. This one need very small amount of heat to overcome the weak force of attraction between the molecules. So for ionic, right, in solid state, the ion cannot move, but in liquid states, right, the ion can move freely. So in liquid or molten state, they can conduct electron, they can conduct electric in molten state of aqueous solution, because they have free moving ion to carry electrical charge. But solid state cannot, because all the ion are fixed position in the crystal electric structure, means they are solid form, cannot move, so ion cannot move, cannot conduct electric. Then for covalent, they are neutral molecule. So neutral molecule don't conduct electric. Then ionic, soluble in water, not soluble in organic solvent. Covalent, not soluble in water, but soluble in organic solvent. So this is the example of the experiment. So this is the experiment that they try to conduct electric for naphthalene. No matter you in solid state or after you hit molten state, it still cannot conduct electricity. But for this one, lead-2 bromide is actually Pb2 plus and Br minus. So when it's in solid state, it cannot conduct electric. But if you heat until it melt, right? When it become molten, the light bulb is lights up, means you're able to conduct electricity in solid state. Okay. So in solution, you also can conduct electric for the ionic. So try to look at the questions here. P is 2.4. This is 2.8.1, 2.8.7. Okay. For ionic, right? For ionic, form between metal plus non-metal. So metal is 1, 2, 3. Non-metal is 5, 6, 7. Okay, for covalent is between non-metal and non-metal. So non-metal plus non-metal. So the numbers will be the same. 4, 5, 6, 7 with 4, 5, 6, 7. Because for ionic 1 donate, 1 receive ma. So in this case, who will become the okay, we'll look at ionic first. Who will become ionic now will be this and this. This one will donate 1, this one will receive 1. So you can mention here. Electron arrangement of Q is 1 valence electron to 1. So Q will donate 1 valence electron to form Q plus. So Q become Q plus plus 1e. Electron arrangement of R is 2.7, 7 valence electron. So R will accept 1 electron into the outermost occupied shell to form R minus. So R plus E will become R minus. So the opposite charge Q plus and R minus is strongly attached by electrostatic force. So the formula will be QR. So you can see here. This one original is 2.8.1. He donate 1 to here, so 2.8.7. So you can see one of the electron is different shape. Okay. For here, in order to become covalent bond, you need to be 4, 5, 6, 7, 4, 5, 6, 7. So 4 and 7 will form ionic. So how do you write this? Very simple. P is 2.4. R is 2.8.7. So this one need 4 more. This one need 1 more. If you cross, you will get PR4. So draw 1 P surrounded by 4R. Okay, so electron arrangement of P is 2.4 and 4 valence electron, you need 4 more to become stable. So you'll contribute 4 to achieve stable electron arrangement. So electron arrangement of R is 2.8.7 and 7 valence electron, he need 1 more. He'll contribute 1 electron to share. Then 1P, PR4 means 1P will combine with 4R. So it becomes PR4 is 4. Then you can see from here, this is electrobromide and naphthalene. Then they ask that what is the difference in the observation? So for electricity and melting point. So for electricity, electrobromide conduct electricity in molten steel aqueous solution because it has free ion to conduct electricity. Then electrobromide in solid state consists of ion at fixed position in crystalline structure, cannot move. So no free moving ion, so cannot conduct electricity. Naphthalene don't conduct electricity in any state because they are neutral molecule and no free moving ion. For melting point, for lead-2-bromide is very high because it got strong electrostatic force between them. A lot of heat is needed to overcome the strong electrostatic force. So melting point on naphthalene is lower because weak van der Waals force between the molecules. So very little energy is needed to overcome. So look at the sample question here. These are the questions that they actually give you the drawing. So you have to from here need to know. This one now look at the drawing is 2.8. This one is 2.8. But before you donate receive, because positive will donate electron. So this is 2.8.2. This one is 2.6 original. Then from here, K, you can see that its original is 2.6 and 2.6. So how do you explain? We started with this. One is covalent, one is ionic. So for J is 2.8.2, 2 valence electron. Then for K is 2.6. So J will donate 2 electrons to become J2 plus. Then for K 2.6 will need to receive 2 electrons, become K2 minus. Then they are strongly attached by strong electrostatic force. Done. Then for the other side, you mentioned about K need 2 more to become stable. So each of them will take share 2 pair, so they become K2. Then for here is the same. They're asking for compound J and K. So since J is ionic, K is covalent. So you can mention the boiling point for sodium chloride is high. Naphthalene is low. I did request for some example. So you can give ionic as a sodium chloride as an example. Then after that, for the J is covalent, can use naphthalene as an example. So sodium chloride, melting point is high, a lot of heat energy is needed to overcome the electrostatic force between ion. So naphthalene is low because it's a little heat energy is needed to overcome the force attraction between the molecules. Then one conduct electricity in solid state, Do not conduct electricity in solid state because ion a fixed position in crystal structure. Conduct electricity in molten aqueous state solution because molten it has free moving ion. Then nepheline don't conduct because it's neutral molecule, don't have free moving ion. Then this one soluble in water, not soluble in organic solvent. Then covalent soluble in organic solvent, but not soluble in water.